It was early morning on July 16, 1945. At the Alamogordo Proving Grounds near White Sands, New Mexico, a select group of atomic scientists and U.S. military personnel had gathered. On a tower in the distance was a secret, untested nuclear device codenamed Trinity. The countdown began, and then the button was pushed. In a flash of light, the nuclear age came bursting on the scene. America had won the race to unleash the destructive power of the atom. It was clear this power was awesome, too awesome to remain untamed. So began the quest of science to harness that power for peace, while others feared it would lead to another war more destructive than any since the beginning of time. The beginning of time. The beginning of time for man? The beginning of time for the universe? How did it all begin? What keeps the awesome power of the atom in check until it bursts forth in those uncontrolled nuclear reactions? Scientists have deciphered the laws that govern them, but who made the laws? Who made the atoms? And who made the earth, sun, moon, and stars? Hi, I'm Don McIntosh, and in this program, we'll be exploring the scientific mysteries of the universe and the controversy over how it came to be. But first, on Christmas Eve in 1968, the Apollo 8 astronauts Anders, Lovell, and Borman gave an impressive answer to the question of who made the heavens and the earth when they relayed a special message back to Earth from their orbit around the moon.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good. And God divided the light from the darkness. And God called the light day, and the darkness he called night. And the evening and the morning were the first day. And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters." And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. And God called the firmament heaven, and the evening and the morning were the second day. And God said, "Let the waters under the heaven be gathered together into one place, and let the dry land appear." And it was so. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
The world was stunned. Like a voice from the heavens, it was reminded of the Creator's claim in Genesis that he had done it all in 6 days. But most modern scientists long ago rejected the 6 literal days of creation in favor of Big Bang's theory of geologic and cosmic evolution over 6 long geologic and cosmic periods. They claim it's one of science's greatest achievements of all time. But 2 U.S. scientists, Dr. Robert Gentry and his son and associate Dr. David Gentry, now prepare to show why it's actually scientists' greatest blunder, not its greatest achievement. In particular, instead of the universe being the same everywhere, which is Big Bang's key assumption, they have discovered astronomical proof the universe has a nearby center. They believe this startling discovery may yet attract the interest of people of all religious persuasions and even those who have none, for they believe it points to the great white throne, the celestial dwelling place of the God of Genesis, the same God who gave the literal 7-day creation commandment to Moses on Mount Sinai. With this background, Drs. Robert and David Gentry began to unfold the exciting saga behind their discoveries.
The excitement really begins by recognizing that the Hubble Space Telescope and other NASA telescopes have photographed some truly amazing celestial objects within our universe. This is a very long exposure of our galaxy as seen in the night sky. We see it here from inside, looking edge-on through its disk, of billions of stars interlaced with vast clouds of dust and gas, hundreds of thousands of light years in size. And this is a supernova, exhibiting what astronomers have called the glowing eye. Then we have NGC 49's cosmic blast. And then the Ant, a planetary nebula surrounding the dying sun-like star Menzel 3. Another exploding star caused the Eskimo Nebula. It's about 5,000 light years from Earth in the constellation Gemini. A complex of mixed nebulosity surrounding the triple star Rho Ophiuchus and the yellow giant Antares. And here's the amazing NGC 346 in the Small Magellanic Cloud. Another exploding star, 3,000 light years away in the constellation Draco, created the Cat's Eye Nebula. V838 Monocerotis is from a burst of light traveling outward and illuminating shells of gas and dust ejected from the central star and has been likened to Van Gogh's Starry Night. And here are the fabulously exotic pillars of creation in the Eagle Nebula. They're actually spires of rarefied gas and dust hundreds of light years long. And here's a close-up of the beautiful Orion Nebula that we'll see more of later on. These two closely spaced galaxies, nicknamed the Mice, are 300 million light years away in the constellation Coma Berenices. The variety of shapes and the sizes of galaxies is unbelievable. Take, for example, the barred spiral NGC 1300. And then the starburst galaxy. Here we have Hoag's Object Strange Ring Galaxy. And here is the Antenna Galaxy, showing the interaction of two spiral galaxies. Galaxies are so huge, and their distances so great, that we can hardly comprehend their existence. The beauty and majesty of all these celestial wonders captures the imagination. Take a look at the exquisite detail of these astronomically huge lanes of gas and dust that form a belt around the Sombrero Galaxy. Surely all these galaxies are telling us something of vast importance.
To see what it is, we turn to this special Hubble Space Telescope photo that took 11 days or 1 million seconds to expose in 2003 as the telescope orbited the Earth. It shows several thousand galaxies in a little speck of space the size of a pinhead. It's aptly named the Hubble Ultra Deep Field because it recorded galaxies more distant than any ever seen before, and leads to the estimate that throughout the cosmos there are over several hundred billion galaxies, each with over 100 billion stars. Many small green circles have now been drawn on this image, each one containing the most distant galaxies ever seen. But when magnified, we see that all of them are red. Why? We'll focus on this shortly. For now, we note these distant galaxies must reach almost to the edge of the visible universe. And because we see about the same density of galaxies in every direction the telescope is pointed, we say this is evidence that our universe does have a center, which is astronomically nearby. But this is just the opposite of what Hubble and other astronomers concluded when interpreting his famous redshift discovery. So which is correct? To find the answer, we flash back in time to the early part of the 20th century. By then, astronomers like Edwin Hubble knew that the Doppler effect could cause spectral line shifts due to the relative motion of the source and observer. A shift toward the blue end of the light spectrum, called a blue shift, was interpreted as motion toward the Earth, and a shift toward the red end, called a red shift, was interpreted as motion away from the Earth. Here's a real astronomical illustration of the Doppler effect. The gases swirling around a distant galactic disk that are moving toward Earth produce a blue shift. Those moving away produce a red shift. It was at Mount Wilson Observatory in the 1920s that Hubble utilized its new 100-inch reflector, the largest telescope of that day, to discover that light arriving from distant galaxies was redshifted in an orderly way. In 1929, he published his findings. The greater the redshift, the greater the distance a galaxy was from the Earth. This was a monumental discovery, as shown in this graphic. that modern astronomy has confirmed. It was also very puzzling. Hubble and other astronomers had observed redshifts of different galaxies but didn't recognize the systematic trends. Previously, the universe was thought to be static and unchanging. Now it was shown to have an unexpected kind of order. This animation illustrates how the redshift increases as a galaxy moves further and further from the Earth. The preeminent question was, and still is, what assumption should be used to interpret Hubble's discovery? Before discussing Hubble's assumptions and the conclusions he drew, we first determine the outcome if the Doppler interpretation is used. In that case, these graphics clearly show that galaxies both far and near are receding from us, spreading out from us, if you please, in an orderly manner. The spherical symmetry of the galactic recession from our observation point is again extraordinary evidence of the existence of a nearby center of the universe. Why then didn't Hubble report this discovery over 75 years ago? The answer is in his 1937 book, The Observational Approach to Cosmology. On page 51, he stated, "The unwelcome supposition of a favored location must be avoided at all costs." On page 59, he spoke of ways to escape the horror of a unique position, which was also said to be intolerable. And on page 54, he emphasized, there must be no favored location in the universe, no center, no boundary. All must see the universe alike.
It's really obvious then that Hubble engaged himself in the most extraordinary denial of fact in all the history of science in his attempt to get rid of the center and demand the universe be everywhere the same. These three graphics show, however, this could not be accomplished using the Doppler assumption. If, for example, observer number 1 sees redshifts of galaxies moving away from his position, and a distant observer number 2 sees redshifts of galaxies moving away from his position, then each will observe a universe full of blue-shifted galaxies mixed in uniformly with red-shifted galaxies. But this is not observed. So it's impossible to get rid of the center using the Doppler interpretation of Hubble's redshift discovery. So, how did Hubble and all astronomers since then evade it? This they did by adopting a new untested assumption about redshift called space-time expansion. As this illustration shows, space-time expansion assumedly causes light to be redshifted as it travels across the universe, independent of the Doppler effect. It was postulated to cause galaxies to move apart and wavelengths of light to expand as space itself expanded. This idea was adopted over 70 years ago, but remained untested until David and I did so and found proof it has always been wrong.
The reason? Light wavelength expansion means the loss of energy. The total non-conservation of energy loss of all the light particles in the universe due to this imaginary process equals over 30 million times the mass of the universe. Details of this are available on the Internet report Archive GRQC 9806061 at orionfdn.org.
Galaxy motion is also assumed to be magically affected somehow, causing each galaxy to move away from every other galaxy as space itself expands, and in this way make it appear the universe is everywhere the same. But it's easy to show it's the greatest scientific blunder of all time. All we have to do is examine what three of the greatest authorities on the Big Bang say when trying to convince their physics graduate students that it is genuine. Of all the disturbing implications of the expansion of the universe, none is more upsetting to many a student on first encounter than the nonsense of this idea. The universe expands, the distance between one cluster of galaxies and another cluster expands, the distance between Sun and Earth expands, the length of a meter stick expands, the atom expands. Then how can it make any sense to speak of any expansion at all? Expansion relative to what? Expansion relative to nonsense. Only later does he realize that the atom does not expand. The meter stick does not expand. The distance between Sun and Earth does not expand. Only distances between clusters of galaxies and greater distances are subject to the expansion. Only at this gigantic scale of averaging does the notion of homogeneity make sense. Not so at smaller distances. No model more quickly illustrates the actual situation than a rubber balloon with pennies affixed to it, each by a drop of glue. As the balloon is inflated, the pennies increase their separation one from another, but not a single one of them expands. From the book Gravitation by C.W. Misner, Kip Thorne, and J.A. Wheeler, published by W.H. Freeman and Company, 1973, page 719 and section 27.5. Here is the balloon doublespeak illustration that Misner, Thorne, and Wheeler's book uses to intimidate their graduate students to accept expansion. But the simple example of galaxies projected on screens at increasing distances from a projector reveals the fatal flaw in their illustration. They show that expansion, if it ever existed, would cause galaxies to expand in size as well as separate from each other. Here is another illustration proving the same point. Namely, if expansion had ever existed, galaxies would have expanded into smithereens. Obviously, no galaxies would ever have formed in the first place.
But as we saw earlier, the universe is full of them, more than 1,000 billion trillion, each one silently testifying that the space-time expansion hypothesis has always been an imaginary effect, and hence that Big Bang has always been nothing more than a big fizzle, just the figment of the imagination of those who vainly tried to wipe the remembrance of God from His universe. While the Big Bang collapses under its own contradictions, we now begin to understand the true significance of Hubble's discovery. There really is a nearby center of the universe. And this cosmic center of the universe illustration shows how galaxies diminish in size and increase in redshift as they move further from the center. So what is the significance of the center? What does it all mean? In Isaiah 40, verse 21, the Bible speaks of God spreading out the heavens, an obvious reference to the expansion of the universe we've been discussing. Also obvious is that their outward motion, their spreading out, implies there is a point of origin, a definite location from which they are spreading out from. Which point could that be?
In Psalm 103:19, the Bible says, "Thy throne, O Lord, is established in the heavens," which we also identify with the location of the great white throne described in Revelation 20, verse 11. It's just that simple. In fact, this graphic briefly illustrates the new cosmic model. It contrasts visible galaxies receding from the nearby center with our recently discovered outer shell of galaxies that encloses the visible universe. Light from the outer galaxies cannot be seen by telescopes because vacuum gravity has shifted it down to become the well-known cosmic microwave radiation. My December 2004 article in Perspectives in Science and Christian Faith identifies the galaxies in the visible universe as originating in the Genesis creation, while those in the outer shell are ascribed to a separate, earlier creation. This fits with Job 38:7, which shows that intelligent beings existed prior to the Genesis creation. With this background, we will now see why the nearby throne has special relevance to the Genesis six-day creation. To us, the logical conclusion is that God deliberately created the universe so as to reveal that His throne, the great command center of the universe, is located so astronomically nearby that it could be within our own Milky Way galaxy. On this basis, we here on planet Earth are definitely in a privileged position in the universe. It is reasonable that Earth should occupy a special place in the cosmos because the Creator Himself lived here for over 30 years. We thus believe God is now using the heavens to confront humanity with astronomical proof that He is the Creator of the heavens and the earth. Moreover, this view exactly fits with our earlier scientific discoveries of Earth's rapid creation and young age, as shown in our earlier videos titled Fingerprints of Creation and the Young Age of the Earth, and my book, Creation's Tiny Mystery. More information on these resources is available at halos.com and orionfdn.org. The scientific community was informed of the downfall of the Big Bang, the discovery of the center of the universe, and its identification with the Great White Throne, plus many other features of the universe in this poster we presented at the April 2005 American Physical Society meeting in Tampa.
We have already discussed the meaning of a number of its graphics. It can be viewed in its entirety at this APS website.
Along with this, it's fascinating to think about what we would find if we were to travel to the throne itself. So let's take a trip there right now through the magic of computer animation. And as we prepare to leave Earth's orbit, we see the night sky coming into view with its millions of city lights far below. The sun blazes into view along with the constellation of Orion, and we begin to accelerate, passing our sun at 10 times the speed of light. Years ago, I suggested in a scientific publication that the Orion Nebula was the space corridor to the throne, and now as we approach the stars making up the constellation, each one a different distance from Earth, we're going over 1 million times the speed of light. As the stars of Orion pass behind us, the Orion Nebula, 1,500 light years away from Earth, looms larger and larger as we begin our deceleration. This nebula is a vast cloud of rarefied gases and dust 100 light years across. It is illuminated and being boiled away by this handful of very bright and very hot blue-white giant stars called the trapezium. Hundreds of smaller sun-like stars form a cluster around them. As we pass through the cloud and emerge on the other side, we see heaven itself and the throne of God described in Revelation 21:16 as being a glorious city, 350 miles square. Verses 19 and 20 tell us its foundation is made of 12 layers of precious gemstones and surrounded by a 250-foot high wall containing 12 gates, 3 on each side. As we enter through one of the huge pearl gates described in verse 21, we see within the city, on top of its huge mountain, spoken of in Isaiah 14:13 and Revelation 14:1, the indescribably glorious and holy throne room of God pictured in Revelation 4. We reverently enter and approach closer to His throne, and there before us, according to Hebrews 8:1 through 6 and Revelation 11:19, is the same fourth commandment of the 10 given to Moses on Mount Sinai, which tells us of God creating the visible universe in 6 days and resting on the seventh-day Sabbath. Jesus tells us in Matthew 5:18 that it has never been changed and that He is there now representing us before God. The fact that God created the universe to specially point to His throne and His seventh-day creation commandment tells us it is just as valid now as when given in Eden.
It will be of spectacular importance as the end-time events continue to unfold before us. How could it be otherwise when we see the first angel of the 3 in Revelation 14 commanding with a loud voice in verses 6 and 7, "For everyone to worship Him that made heaven and earth and the sea and the fountains of waters."
We believe the timing of this discovery, that the universe really does have a nearby center, may mean God arranged all this to come to world attention before the greatest and most spectacular event of all time,
the second coming of Christ in the clouds of heaven. As you can see, He is at the throne, ministering as our great high priest as described in the book of Hebrews. But very soon He will return. Retracing our steps now, Jesus comes out of the most holy place of the heavenly sanctuary on his way back to the earth. The angels surround him, forming a vast cloud like the one described in Acts 1 verse 9 that the disciples saw when Jesus was taken back to his throne at his ascension from earth 2,000 years ago. And just like Revelation 1 verse 7 says, as he enters the solar system, every person on earth will be able to see him approach, at first like a dark storm cloud, growing larger and brighter, until, according to Revelation 6 verse 14, the atmosphere rips apart, and suddenly, there he is. His brightness, like pure energy, consumes all who turned against him and rebelled. Yet we who are waiting for him will he save from that destruction. That's what it's all about. The Lord is trying to help us prepare for this great and glorious event.
Lastly, believing as we do that God intends to use the great works of creation presented in this program, as well as the saga behind these discoveries, to awaken a great many to a sure realization that Christ's second coming is imminent, we urge one and all to join us in a worldwide effort to spread this good news so that it will go as fire in the stubble. Thank you for watching, and may the God of creation bless you. To order this video, call 1-800-467-6380 or visit our website, halos.com. Hello, I'm Don McIntosh. We're glad that you've joined us for this special presentation by Drs. Bob and David Gentry, and we're going to take a closer look at that presentation. We're in the studio with Dr. Gentry right now. We're going to talk a little bit about the presentation, hopefully looking a little more in depth so we can understand more fully what we've just heard, and hopefully I'm going to represent you and ask some questions that you would have asked if you were sitting where I am. So you're going to lead us through that. This presentation was focusing mostly on the Big Bang Theory and looking at a completely different take on the data. The data is the same, but the conclusions are different.
Let me just say one thing about one part of what you said. The general consensus in the world is scientists are honest, open-minded. If they see anything that challenges the conventional viewpoint of anything, any theory, they're all going to jump in and check it out and so forth. The fact of the matter is that scientists are human beings, and they have agendas. They have philosophical viewpoints, and the fact of the matter is, as we're going to see in more detail here in a few minutes, that they have not been, absolutely have not been open to rethinking their postulates and looking at them to see what might be there in terms of a different viewpoint as it pertains to creation itself. Here it is. The problem of explaining the existence of the galaxies has proved to be one of the thorniest in cosmology. by all rights. They just shouldn't be there. Yet there they sit. It's hard to convey the depth of frustration that this simple fact induces among scientists. Time after time, new developments have come along, and it has seemed the problem was solved. Each time the solution turned soft, new problems developed, and we were right back where we started. Okay, so basically we're saying here that, you know,
A problem, he's saying there's a problem when we see all these galaxies there. He's saying, look, I mean, this doesn't make sense with the other stuff we're presenting. Well, what's the problem with seeing the galaxies there for him?
well, basically they're saying they don't even have a good model that it can be validated. They got all sorts of assumptions that go into. You can sit down at a computer and, you know, basically engineer some assumptions to go with, you know, a computer animation, and you can produce galaxies, obviously, with the computer and with certain assumptions. What he's basically saying is they don't have any real basic fundamental assumptions that can explain the formation of the galaxies, but very, very few people will admit what he is admitting right there.
Okay, so he's admitting big problem with existing Big Bang Theory, all kinds of problems with it, but not too many scientists even admit that.
Absolutely.
And you're building now on this admittal to look at the data a different way.
That's right. So let's take a look at Hubble. Of course, there he is. Now listen, telescope, looking through it back in the 1920s, and he comes up with the fact that indeed the light from the galaxies is actually shifted to the red end. And this is a very common
You believe
phenomenon.
that?
Well, as a physicist, I have to believe it because I can go in the laboratory and actually move a sample away from a spectrometer, and you can actually see the lines, the spectral lines actually move. And the policeman can actually, he actually uses that. He uses microwave, of course, shoots, you know, the beam at a car if it's coming toward you. Then basically using the fact that indeed the wavelength has shifted toward the blue end because he's coming toward you, he can easily, the computer inside there will calculate, you know, your speed, if it's going away from you, and so forth. So it's used thousands and probably millions of times.
So it's observable, it's something that can be accepted as
Absolutely.
definitely a fact.
In fact, that's exactly what astronomers before Hubble had been doing. They put up a spectrometer on the telescope, and they saw that there were some galaxies with shifts of light to the red end of the spectrum, and they clearly said, these must be moving away from us. This is the Doppler effect.
Well, let me ask a question that may display more of my ignorance than I'd like to, but you know, are there other things that can cause objects to look red? I mean, I see the sun go down, it looks red.
Sure. Well, that is because as the sun goes down, if you're in the desert, of course, or if you're in whatever place that has a lot of dust in the atmosphere, the light coming through, the light from the sun, of course, is a composite of many, many, many wavelengths, okay?
Okay.
Well, when the light comes through and it's near the Earth's surface going down, what happens is that the dust then will preferentially absorb the blue and the green and so forth, and so then what you have left coming through is the red.
Okay, so this is a totally different thing than the redshift.
This is, yeah, the light itself, the spectral lines themselves are not shifted. The same spectral lines remain in the red region and so forth.
Okay,
now,
so we all learn. You and I both learned together on that. Hey, no, but these are the kind of questions that come to my mind. Okay, so this redshift, though, anytime you see it, or anytime you observe, you're going to see that red as something moves further away.
yes, there is one other explanation which is commonly understood, actually experimentally determined, and that is gravity itself. If you're up in a satellite and light then comes down to where you are, it turns out that there is what we call a gravitational shift of the spectral lines. If indeed light from a distant object coming toward us, that is up in a satellite, it would actually have the spectral line shifted toward the blue. However, if it's actually rotating, then there is what we call a second order Doppler effect, and it shifts it to the red. But basically, for our discussion here today, gravity will also shift light either to the red or to the blue end.
Depending on which way it's going.
That's right. Because the Earth itself has what we call a gravitational field, you know that. We're sitting here today, we're not floating in space. And so, indeed, light then that is going through a gravitational field from a higher to a lower potential will have it shifted. Now, the shift, however, is very, very, very small here on Earth. And you have to have special equipment, special experiments in order to see that. But for all practical purposes, when indeed the initial results of Hubble were being published and discovered, there was only one known effect that indeed could explain this redshift, and that was indeed the Doppler effect. And so, as we look at then Hubble's experimental data, you can see that the redshift of the galaxy in the vertical line, the distance of the galaxy from the Earth, horizontal line, and we have then the Earth there at the lower left-hand point, galaxy 1, 2, 3, 4, 5, and we can see that the actual line itself, the lines themselves are going from, you know, white to yellow and more yellow and orange and then red. Okay, so what was Hubble's reaction to all of that? Well, the simple, obvious reaction should have been that indeed his result was a monumental discovery, presented astronomers and cosmologists with a huge dilemma, because they were accustomed to interpreting the galactic redshifts according to the Doppler principle. Well, okay, let's put that in, the Doppler principle now. Let's substitute then the increasing velocity of the redshift on the left-hand axis there, the vertical axis. So instead of redshift, it is now velocity as well as redshift. The distance from the Earth is the same. Now remember that prior to this time, astronomers had seen some galaxies that were basically shifted toward the red. Okay?
They'd seen that, they observed that through telescopes or whatever.
That's correct. But now one of the things that Hubble did prior to his discovery of the redshift, the relationship itself, in using the 100-inch telescope, the largest one of that day, astronomers did not even know that there existed what we call galaxies, these galaxies that we see so easily.
They couldn't see them.
The telescopes were of such a nature they could not resolve whether the specks of light that they saw were really another island universe, so to speak. But now Hubble, with this new telescope, focused on these more distant galaxies, and he found, we won't go into the details, he found proof that indeed there are other galaxies like ours, the Milky Way. And this resolved a huge controversy in astronomy. Until that particular time, it had always been up in the air. Are we living, you know, within a single galaxy, and are these objects, you know, distant objects? Everything within our galaxy, stars or whatever. So he resolved that, and he got a very, very, you know, high acclaim for this discovery. And so when he turned his attention then to the universe, in other words, using the 100-inch now to measure the redshifts, he came up with this fact that indeed, remember also that for 1,000 or more years, 2,000, whatever, astronomers had always felt that indeed the universe was static, immovable, the bowl of light. They would see the stars, and they didn't seem to move.
Okay.
And so as a result of that, everyone believed we were living in what is called a static universe.
And Hubble his discoveries just blew that out of the water.
Well, we can see from the slide here,
Galaxy 1, 2, 3, 4, all the way. He saw, he documented or proved why there was more than just one.
well, in his...
And the shift also showed that there was movement.
Well, if we interpret it that way, it would have shown there was movement. Okay, now, if indeed he had only looked in a single direction, and his early observations, you know, he didn't have a long observing time, if indeed it was found, other astronomers jumped in, other telescopes were devised, manufactured, other astronomers looked at the universe, if it was found that Hubble was only seeing this unusual redshift relation in one direction, people would have said, well, this is very, very unusual in itself. But what they found, of course, is no matter which way you turn the telescope, you're always getting this same redshift relation. So all of a sudden then it became apparent, first of all, that there was order to the universe. It was known, of course, there was order to the planetary
Any
system.
way you look, it's going to look the same, and it's going to document that it's ordered the same way.
Order.
Okay.
And so as a result of that, this new order, you know, this is a schematic, this is a graphic that simply shows that indeed the farther the galaxy is away from the Earth, the redder it becomes. And the redder the galaxy, the faster it's moving away from the Earth. You can clearly see the movement here, so to speak, graphically, and you get the idea very clearly that you're looking at something, we're near or at the center of this vast distribution of galaxies.
Well, let me ask you a question on that point, because as I've listened to the presentation and thought about it, a question came to my mind. That's true when we're sitting here or when Hubble was doing his thing here, but let's say we could transport him and take him 1,000,000 miles away, would he still see a redshift going every way from his new location?
Well, now that was something that really came into focus as Hubble and others were actually beginning to try to devise an explanation for what they're seeing.
You mean my question, they considered that question?
Absolutely.
Okay.
Absolutely.
Okay. I feel, I guess, okay about that. Well, what did they find?
All right.
Or what did they, I mean, there's no way he could go 1,000,000 miles away.
That's true.
So, I mean.
But we can see from this schematic right here that he obviously realized if he used the Doppler interpretation,
Right.
that indeed, you know, he would seem to be at the center. Now, your question, which they very quickly, well, I say in a year or so, they really had their wheels turning, figuring, what in the world can we do? Why? You see, one of the principles of science is, if you find something new, what you try to do is use the simplest explanation you can find and generally is true. It's called Occam's razor. All right, so what does Hubble do? He doesn't like that idea. And in his book, The Observational Basis of Cosmology, 1937, he says the following: the assumption of uniformity has much to be said in its favor. If the distribution, talking about the galactic distribution, were not uniform, it would increase with distance or decrease. But we would not expect to find a distribution in which the density increases with distance, symmetrically in all directions. Such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a
Central Earth. Okay.
Now, in the Dark Ages, what entity promoted?
The church.
The church.
The church said we're the center and the world's flat.
In other words, well, once they found this out, their Earth being flat went by the wayside, of course.
Right.
But the fact of the matter is,
so he's trying to stay away from that because it's associated with what's considered a prehistoric or something that's been relegated to the dustbin, a center to the universe.
well, yes, this hypothesis, or the hypothesis, cannot be disproved. That is, the possibility of the center. But it is unwelcome and would be accepted only as a last resort in order to save the phenomena. In other words, if we have to use that in order to explain what we've seen, we'll resort to it. Therefore, we disregard this possibility and consider the alternative, namely a distribution which thins out with distance. Now remember, in him saying that, that was the time in which there were only a few observations, and he was making comments about what he presumed to be the distribution and so forth. The main thing that we're getting at here is that Hubble is saying this idea of a center is just, unwelcome, for sure. Now let's look what else he has to say from the same book. To this principle has been added another proposition that all observers, regardless of their location, will see the same general picture of the universe.
So now, that's my point, no matter where they would be, whatever position.
They liked what you said.
They liked what I said.
That's right. If you'd been back in that time, they
well,
would have
I wasn't agreeing. I said, what would happen if you took them 1,000,000 miles away? I was asking, what would happen? Would you see the same thing?
I know. Well, they have a very good reason for wanting that. Exactly.
Okay. All right.
That all observers, regardless of their location, will see the same general picture of the universe. The second principle. Now, what principle is he talking about? He's
That
talking about,
idea that they'd see the same thing.
That's right. Now, he's calling it a principle.
And it's not a principle,
What is it?
an assumption.
Assumption only. It's a sheer assumption. He admits it.
Okay.
Nevertheless, it leads to a rather remarkable consequence, for it demands that if we see the nebula all receding from our position in space, in other words, he's now saying some way, somehow, we're going to get them all receding, okay? Then every other observer, no matter where he may be located, will see this nebula all receding from his position. However, the assumption is adopted. In other words, we're going to adopt this assumption, and what is it? What else does he say? Why are they adopting this assumption? There must be no favored location in the universe.
In other words, no
center.
Okay.
No boundary. All must see the universe alike. They're decreeing, Hubble and the astronomers of that day were decreeing that, if you go from here to the vast reaches of the universe, take your telescope, what are you going to see?
Same thing, he said.
Same thing. In order to ensure this situation, the cosmologist postulates spatial entropy and spatial homogeneity, which is his way of stating the universe must be pretty much alike everywhere in all directions. That's the fundamental premise that upon which all the Big Bang hangs. Assumption. Now, you remember the one that we read earlier at the very beginning? Weinberg is saying one dark cloud hangs over the standard model of the Big Bang. Cosmological principle. He's admitting that indeed, you know, we really don't know for sure.
So what you're saying with this is that the Big Bang assumption that you could go 1,000,000 miles away, which was my original question, is just that, an assumption. But Hubble's initial reaction to what he was seeing was, it looks like we might be at the center of things.
Got it.
Okay, and he didn't like that.
He didn't like it. Didn't want it. Not only Hubble, but Hubble was not in a vacuum. He happened to be the leading astronomer of the day because, you know, he had previously discovered there were galaxies.
Now let me ask you this question. Since we can't really transport ourselves 1,000,000 miles away, there's really no way to test that out.
Well, most people thought that was true, but the fact of the matter is, there is a way. We'll get to that.
Okay.
Continue. That, it's most important that we understand indeed there is a way to test that in the here and now.
Okay.
All right, let's continue. First of all, we have to understand that why couldn't Hubble incorporate this idea of everywhere in the universe being the same and use the Doppler interpretation? Well, it's right here in our graphics. Indeed, you know, you have an observer here on Earth, and he sees those arrows, of course, represent galaxies moving away, and the length of the arrow represents the Hubble relation. The greater the distance, the greater the velocity. And then, suppose, you know, there's another
That's the guy 1,000,000 miles away now. He's looking.
Let's assume he's at 10 billion light years away.
All right.
10 billion light. He's at the edge of the universe as we see it today. And he looks out, and he just happens to be looking in the direction of us, back here, okay? Now, we've decided that the universe looks like there are redshifts, for sure, even out to his position 10 billion light years away.
But when he looks back...
When he looks back, because Hubble and others say that indeed he's got to what? See the same thing.
So he would see a redshift moving this way, they say.
Well, he would see, no, he would see...
From his center.
No, he would see, look at it. He would see galaxies moving away from him.
Okay.
Right, that's what he's got to be able to see if he's going to see the same thing, right?
Right.
But now, what are we going to do about the galaxies that we saw moving away from us that are going toward him?
So how does he answer that? That's a big dilemma.
That shows, that's proof, absolutely proof, that you cannot accept the idea that indeed everything is moving away from everything else and all the universe is the same, and use the Doppler principle. Okay. You have to invent something new. That is the dilemma they found themselves in. They had to invent something new in order to explain why, if you're at distant reaches of the universe, why you would only see redshifts and not redshifts and blue shifts if you just accept the normal Doppler effect. Big, big, big question.
Big problem. So, I mean, simply put, let's see if this analogy works. You got one guy in the middle of the blackness of night. He's shining a flashlight that way, and the light's going away from him. And he says, I wonder if it probably is the same everywhere. But then you drop somebody as far away as you can, they shine a light, and they both see the light shining at each other. It's a problem.
That's right.
Okay, all right.
On the assumption, now that is under the assumption that indeed the Doppler effect is the reason for the redshift.
Okay.
All right, so they say we don't like, and Hubble and others said, oh, wait a minute, we don't like this idea because, you know, that's an assumption that we see we're at the middle of some distribution. The other guy's got to be at the middle of another distribution. Still, you got to have center. So we want now, in order to get rid of a single center, it's okay now, they want to have multiple centers no matter where you are in the universe. We want to get rid of the single center. That's the purpose of their ideas. That's the purpose of their plans. That's the purpose of everything, to get rid of a single unique center. And so they said, how can we do this? Well, this was all happening in the early, before Hubble actually made a discovery, 1922, 1924, and also 1927. Back in 1917, Einstein had developed what he called the field equations of general relativity. Okay? He solved the field equations for one solution. That one solution was, in essence, formatted according to, what it meant was that the universe that we have was basically in agreement with the static solution of the universe. Well, Einstein thought that was all great, and in fact he was thinking static universe, and so forth. However, in 1922 and 1924, a Russian scientist, Alexander Friedman, took hold of Einstein's equations, and he said, you know, there really is another solution to the field equations here. It's a solution that involves time. Einstein's initial solution of the field equations only involved gravity. But now we've got some gravity and space, but no change in space volumes. Anyway, Friedman and then another person, Georges Lemaitre, a Catholic priest, in 1927 solved the field equations the same way that Friedman had done, and they both ended up with the idea, well, you know, if we use the idea that there's a time element involved in the solution of the field equations, we'll get a different solution, and that different solution tells us now that space itself will have the ability to actually expand with time. Aha. So back in 31 now, this is several years after both Friedman and Lemaitre had made their discoveries, there was a scientist, physicist, astrophysicist in England, Arthur Eddington, very, very, very famous, well known. And he was wondering how can we actually put all this together and find a solution here to get rid of it. He also didn't want the center. Well, no one in astronomy wanted the center, the unique center. And they heard about then, Lemaitre told them about this expanding space-time solution of the field equations, and immediately Eddington got his original paper and published it over there in a well-known British journal. Up until that time it wasn't well known. And to make a long story short, the idea was simply as follows, as we can see on this graphic. The Big Bang, I labeled it Big Bang science fiction about the redshift.
Okay.
Because here we have, first of all, the idea that instead of the universe being a static universe and volumes and so forth not changing in time, all of a sudden we've got the solution of the field equations that says, in theory, that space itself can expand. Take a box of a certain volume. Yesterday, supposedly, it was smaller. The day before that, even smaller, volume-wise. Or tomorrow, it's going to be larger. And so that was one thing they did. First of all, to assume that the universe, you know, was governed by this other solution of the field equations. Why were they doing this? Ultimately, they wanted to get rid of the unique center.
Idea of a center that came from the logical conclusion of the Doppler effect.
That's right.
Okay.
And so that wasn't enough, though, just to say that space itself is expanding. That enabled them, you know, someone said, well, wait a minute, maybe there's a beginning. And the beginning is, well, maybe everything was very, very small to begin with. And that appealed to the Belgian priest, Georges Lemaitre, because he said, well, maybe that was the finger of God. God touched the universe and just everything went from there. And so that was the initial reaction of, you know, of those people who believed in the Bible or God, saying, you know, well, here we've got the ideal thing, we can marry, you know, this new idea with a new with an interpretation of the Bible, you know, that we'll get our cards together here and so forth. New ideas, new theory, but we're going to put it in the framework of still believing in the Bible. Now they were still faced with something else because the light was shifted to the red end of the spectrum. And they couldn't use the Doppler effect because that would be a huge contradiction. So now they're going to say that when space itself expands, guess what? Wavelengths expand. Wavelengths of light. Just coming across this room as we sit here right now. In theory, they are expanding. Very, very small amount. We couldn't measure it unless we had, well, it's so small that you wouldn't be able to measure this amount. But anyway, the whole idea was, as you can see from those schematics, box, small box, the wavelength, very, very short. Next box.
Wavelengths get bigger and then they get larger.
And it gets redder. Big, big, big thought here. And so they said, let's pursue this. And here's another picture of it, of course. The top up there would be a circle, and then you can see the little sine waves going around and around and around, as if, you know, the light were going around the universe. And then the circle expands, representing expansion of space, and the wavelength gets larger. And guess what, though? Remember we talked about non-conservation of energy? That's where the non-conservation of energy comes in, because the energy of light is inversely proportional to the wavelength. So if you have something with a small wavelength, it starts out with a higher energy. Something with a much, much longer wavelength, you've lost energy. And
this would be opposite that law of conservation.
Well, that's what Harrison was talking about. Non-conservation of energy. You know what? It's hardly ever mentioned. Book after book after book in cosmology. You
They
can
don't
read.
bring up this problem.
I want to tell you, and we'll go on, we'll talk about this a little bit more in a little while. David and I have written a report that's published on what is called the archive, in which we showed, it says over there on the left side of that schematic, demands a non-conservation of energy loss equal to a gargantuan 30 million times the mass of the visible universe.
So it's impossible.
We put it out on the archive. It's available to scientists all over the world since 1998. And no one is basically, thus far, contesting what we're saying. The fact of the matter is, that's a prediction of the theory. And a lot of people, like Harrison, will admit, but they have never put that calculation in any cosmology book or any report that we've been able to find. It wasn't ever published until David and I did so in 1998. So
that's the third or fourth major problem we're seeing here.
Yes. Now, interestingly, as a sidelight here, when I was in graduate school, University of Florida, I was taking a course in cosmology about the Big Bang. And I was absorbing it all. Great things are happening in the universe. And how can we explain everything? Big Bang, Big Bang, Big Bang. However, one day in class, the professor got on the topic of this particular issue we're talking about, wavelength expansion of the Big Bang. And I can remember, he started on the left-hand side of the room. And the blackboard was probably 30 or 40 feet long. It was a big room. And so he said, what we're going to do here is show you how, the Big Bang explains the redshift relationship of Ebb and Hubble. So he put it over here and he wrote the symbol for lambda. And he wrote, basically what we just saw here, small wavelength.
Larger in a box, right?
Then, in this case, though, he didn't even use the box. He just sort of did
just
the
told
sine
you.
wave.
Yeah.
And then he started walking across the room, and he'd get bigger and bigger and bigger. Then he ended up on the other side of the room, 30 or 40 feet away, and it was significantly larger in wavelength. Okay? And I was listening, absorbing everything. But then it occurred to me.
What about conservation?
I said, wait a minute. I asked the question. I raised my hand and asked the question. I said, what's going on? Because here you've got an energy of the photon, a certain amount, but if the wavelength is increasing over here at the end of the universe or wherever it goes from galaxy to galaxy, it's lost energy. I said, where did the energy go? Well, he walked back over on the left-hand side of the room and started walking back across the room until he got to the other side again. And he looked at the class and he said, I don't know. I don't know. And so after class, the other members of the class came up to me and they said, well, you raised an interesting question. I said, this is really strange. But I guess everybody knows what they're talking about. It's got to be true. Now that happened when I was absorbing Big Bang cosmology.
And you saw the flaw already then. And you didn't know that you had seen a flaw. You thought maybe this guy doesn't know an explanation for it.
Yeah, I just sort of like, it's a theory. It's explaining everything in the world, so it's got to be true. Who am I, a graduate student, to think that, I've raised a question that would be of any significance?
Right.
But anyway, it did stay in my mind.
I can tell that it did.
And so science clings tenaciously to the concepts of conservation. And again, it's good in everything except cosmology. But the very fact of the matter is, if Big Bang cosmology is the reason and the origin of the universe and the explanation for its development, see, that means we've got to be a part of the universe. And so therefore, non-conservation of energy has got to apply to us. Big contradiction.
Big contradiction. So then what was the next step?
Next step. Just in case that someone has a question and thinking that Hubble was the only one that thought about the center of the universe. You're familiar, of course, everyone's familiar with Stephen Hawking and his famous book, Brief History of Time from the Big Bang to Black Holes. Okay? Well, let's look carefully at what Stephen Hawking has to say in his book, page 42. Quoting, at first sight, all this evidence that the universe looks the same whichever direction we look in seems to suggest there is something special about our place in the universe. In particular, how about that? It might seem that if we observe all other galaxies to be moving away from us, then we must be at the center of the universe. There is, however, an alternate explanation.
The universe. Sigh of relief, okay.
The universe Now notice what he says, might look the same, whichever direction, as seen from any other galaxy too.
Might. That's a very key word, isn't it?
The very fact of the matter, that's why Steven Weinberg says, dark cloud hanging over the standard model. This, as we have seen, was Friedman's second assumption. Remember a few minutes ago I mentioned
It's not a principle, it's an assumption.
that Alexander Friedman, you know, discovered supposedly this other solution, and it's really an assumption. We have no, listen to this.
We have
Go ahead and read it.
we have no scientific evidence for or against this assumption. We believe it only on the grounds of modesty.
Can you believe that?
So he's admitting just what you're saying is the problem. Stephen Hawking, he's probably the most well-known
Scientist in the world.
scientist, astrophysicist
In the world.
in the world, and he's saying big problems, it's an assumption, and we're only doing it because we're being modest.
Now, let's explore that a little bit more.
What does he mean by
Why
being
is
modest?
being modest? Well, the fact of the matter is, if you just read on his book, obviously what he is saying is that, you know, if you don't believe that, then we're either at the center or very, very close to the center of the universe.
Yeah.
What are we in this galaxy? See, he's an atheist, agnostic.
Right.
He's not have anything to do with God. In fact, if you read about him, you'll find that indeed his wife was a Christian, and now I can't vouch that this is still the case, very, very conservative Christian, and Stephen Hawking and all of his talking and work and everything got to the point where she said he's almost thinking like he's God. And so my understanding was several years ago there had to be a separation. She just couldn't take it. Anyway, this fellow is so opposed.
And he's admitting, though, in that statement, he's showing actually your whole argument in a very short paragraph. And if he had taken a different position, his book would not be called A Brief History of Time. He would have to be doing a lot of explaining as well.
Well, yes.
Because he'd be standing up and actually standing on the scientific evidence that you've presented and saying, we've got to look at another option.
Actually, it would be much stronger than that, because you see, when he says, as you say, why is he saying this on grounds of modesty? Well, see, because as we mentioned before, for an astronomer, astrophysicist, you know, who, remember, doesn't really have any connection with God whatsoever, he doesn't want a connection with God. He doesn't want the Bible. He doesn't want the moral premises of the Ten Commandments to be meaningful, but he knows if there is a center of the universe, there is a God, and indeed there's only one religion that really focuses on God being the creator. So he says modesty basically is saying, listen, fellas, you know, if it's not modesty, we're there. And we don't want it. You're right. Stephen Hawking is basically admitting what we're saying here today in a very, very concise way.
Yes, he is. That's fascinating.
Most people don't know this.
That's fascinating.
They read the book and they don't understand how strong the evidence is for the other side. Here we are with good old Hubble Ultra Deep Field, thousands and thousands of
galaxies again, the same
you know,
picture.
at the far reaches of the universe, and some of those we remember have been analyzed for their redshift, and indeed the little green circles there are picking out the ones in Hubble Ultra Deep Field, where indeed in the middle of those circles the light was shifted so far to the red that instead of seeing, you know, a bright dot, you were seeing red dots. And so there on the right side of the panel you can see the larger circles. You may not be able to see it clearly, but each one of those larger circles has a red dot in it.
I see that, yeah.
And so indeed, basically, it's essentially true. Observationally, the greater the distance, the greater the redshift, even to the uttermost limits of the universe. Now, go ahead.
All evidence points on the face of talking about Hawking, talking about Hubble, talking about these others that have admitted it. They're saying, hey, look, if we just take the Doppler effect, we're in the center. We've got to come up with something that doesn't put us in the center, because we don't want to not be able to get our PhDs or go to school sort of like you described at the beginning. So we got to come up with something else. They've come up with that kind of thing. But now, if you really look closely, they recognize that it's breaking all of those different principles, like conservation and all those different things. It's not making sense together, and yet that's really given no real play in their books and what they're writing and what they teach their students.
And the reason is because they have adopted the idea that observations plus observations plus observations can be fitted into that framework, just like Ptolemaic astronomy. They just got all sorts of planetary observations can be put into the Ptolemaic astronomical viewpoint, so people thought it has to be true. And so what happened is Big Bang cosmologists failed, the greatest blunder in all the history of science. They never really then tested the fundamental assumption of space-time expansion in the here and now.
Thank you so much for joining us as we've been talking to Dr. Robert Gentry. Dr. Robert and David Gentry have spent a lot of their life looking at these very statements, and they've seen the glories. I hope this expanded discussion has been helpful to you, and may God bless you as you continue to consider the wonders that He has made.